Right. All right, good afternoon. Just leave this here. All right, so I'm going to talk about blockchains and AI. And the talk is going to be in two parts. In the first part, it's going to be a little bit of abstraction. And then in the second part, I'm going to make it concrete by showing you real-world applications of what we are doing at the intersection of these two technologies. Right? So no questions about cryptocurrencies like you did with the previous speaker. Right? We are nowhere close to Reliance, and there are no plans of launching any cryptocurrencies. This is primarily blockchains and AI. And the part of this technology that I'm going to concentrate on has probably received much less attention during the day than it deserves, and that is smart contracts. Right? So I'm going to build on the idea of smart contracts and AIs and show you how these two technologies can potentially come together. Right? But before we do that, let's start with what a blockchain value proposition is. Right? Without looking at the underlying technology, say what does it allow us to do? Right? The fundamental idea, of course, is that the blockchain technology allows us to form a multi-entity network. Right? Each entity maintains its own copy of the ledger. That's why it's called a distributed ledger. Right? The benefit of the underlying technology is that the synchronizations of the ledgers is taken care by the underlying technology. So what you have is a synchronized multi-entity network. The third property of this technology is that this is an auditable synchronized network, which means any transaction or any information that is written into the ledger has the two good qualities of non-repudiation and immutability, and that's where the auditability comes from. The fourth important property is that this ledger can enforce contracts. Now, there's a lot of confusion around the word smart contract, so let me take a minute and say what that means. Unfortunately, the name is a misnomer. Right? There is nothing smart about a smart contract as we think in terms of machine learning or AI. A better word probably is an auto-enforcing contract. Right? What that means is that the terms of the contract, once programmed in a programming language, are guaranteed to execute as per what has been programmed without the intervention of any single party. And that is what a contract enforcing auditable synchronized network means. The last part of this is that these contract enforcing ledger can go one step further. Assuming that you have cryptocurrencies, then they can also transfer payments. And this is a fork in the road. In crypto unfriendly regulations, we stop after the first 4 billets and say that the terms of the contracts have been enforced, and as the previous speakers were saying, we can balance account payables and account receivables. If you are in crypto-friendly regulation, you can go one step further and balance the payments inside the ledger because the contract controls the currency. Right? That's fundamentally what a blockchain value proposition is, and that is the terminology that I would be using throughout the next 20 minutes. Right? Now, the part that I want to draw your attention to is that when we say that the blockchain is a multi-entity network, what do we mean? Who are these entities? Right? In a public blockchain, these entities might be individuals, human beings like you and me. In a B2B network, in a permission blockchain, these might be enterprises. If you want the government to participate as a regulator, you might have government as one of the entity. But the question that I want to pose to you, and probably to make you think a little bit, is can an AI agent be an entity in a blockchain? Right? Why would you want to do this? We'll come to that in a minute, but this is the seed of the idea. Can an entity, which is an AI algorithm, be part of a blockchain network, and what does that enable? Right? Before I go any further, let me say what do we mean by AI. Again, a highly abused word. Everybody has their own interpretation. So broadly, if you take a step back and say, what do you mean by AI? There are 3 kinds of AI algorithms out there. For those of you who are not from this background, I'll quickly summarize what each one of them means. The first kind of AI that we see is supervised learning. What this means is, assume that you have a bunch of images of fruits, apples, oranges, bananas, and so on and so forth. Right? And a human has sitting down and said, these are apples, these are oranges, these are bananas. And you give a new image of a fruit to the machine. The machine says, this is an apple. This is what we call supervised learning. It basically learns from historical data, it learns from historical label data, and when you give it a new image, it says this is an apple. The second kind of AI algorithms are unsupervised learning algorithms. In this case, there are again a bunch of images of fruits, apples, bananas, so on and so forth. You give it to the machine, but you don't really tell the machine that this is an apple or this is a banana. You just give it a bunch of images and that's it. Now when you give this machine an apple, it doesn't say it's an apple. It just says this thing looks like these other things, and these other things are apples. Right? That's what you know. But it basically says here is this thing which looks like this thing. The third and probably lesser well-known part of AI is reinforcement learning. In this case, the machine, you give it a bunch of images. The machine does something with this. Machine doesn't know that that it looks like something else. It doesn't know it is called an apple. What it learns is that if I consume this thing, that is good for me. Right? So it's basically a value action paradigm, and that's what's called reinforcement learning. So that is what we mean by AI. Now, go back to the previous slide. If you remember the previous slide, we said blockchain is a multi-entity network, all the nice properties that we knew about blockchain. What does it mean to have one of these algorithms as an entity in a blockchain network? What would that enable, and why would we want to do that? Okay. The first value proposition that we see in this space is how AI can help blockchains. And in one line, the summary is that AI algorithms can be oracles for smart contracts. Right? So to expand on that line, let's again narrow down what exactly a smart contract is. A smart contract is fundamentally a piece of code which automates the payments between multiple entities as per the terms programmed in it. That's what a smart contract is. Fair enough? Now think about it for a minute. If you have given the authority to transfer payments to a piece of code between different entities, that piece of code has a lot of responsibility. That piece of code should therefore know under what circumstances how much money should be transferred from which party to which other party. In blockchain literature, that entity which informs the smart contract about something in the real world, based on which the smart contract makes a decision on when to transfer value and when not to transfer value, is called an oracle. And we believe one of the value propositions for AI algorithms is to act as oracles in smart contracts. Okay, let me give you some examples. Consider an insurance contract. Let's take a crop insurance contract. Right? Every insurance policy is in fact a contract. It's a contract between the entity which purchases the insurance policy and the entity which sells the insurance policy. Right? In such a scenario, before the payment has to be released, remember, the payment release is now the responsibility of the smart contract and is automated. So the conditions under which the value can be transferred has to be determined by the smart contract. Now, how does it do that? How does the contract really know whether the crop in a particular farm has failed or not? Now consider, can we use satellite images for this? Can we have a satellite image-based AI system which acts as an oracle for an insurance contract, and you begin to see where these two technologies can come together. Another examples are logistics contracts. Right? Consider a company which has given a contract to move a particular set of materials from point A to point B, and there are strong conditions on the route that this vehicle should take. Right? You might have GPS data, you might have fuel consumption data, what have you. Can algorithmically you determine whether this vehicle has deviated from the path or not? If you can do that, again you have an example of an AI agent acting as an oracle for a smart contract. Let's look at a third example, public-private projects, where government gives out projects to private contractors to actually build some physical infrastructure, and the terms of payments are determined based on the progress of the project. How do you measure progress of the project sitting in Delhi or at the capital of the state in a remote faraway place? Can we have time-lapsed images either from satellites or some other source which can then be analyzed and therefore the contractual payments can be made? All these three are examples of how AI agents can act as oracles for smart contracts and a good use case for how these two technologies come together. The second broad theme is the other way around. What can blockchains do for AI? Right? This is the reverse problem statement. And to understand this value proposition, here is a picture from a recent paper. Right? What it is I would like to draw your attention first to the red dots. Right? The red dots are artificial agents. They are AI algorithms, state-of-the-art AI algorithms. And you will see that a lot of them rank very high on computational capability, and a lot of them rank very high on autonomous capability. Now switch your attention to the blue dots. These are biological agents, things like ants, bees, and humans. Notice how they rank very high on social intelligence, whereas the biological agents rank very high on social intelligence. The artificial intelligence algorithms that we have don't really rank very high on the social aspect. Now, here is what it means. Go back to the definition of reinforcement learning. We said reinforcement learning is about a machine learning that eating an apple is good. Now, assume that you have 10 different RL algorithms. Each one of them has to independently learn whether eating an apple is good or not. But if they could talk to each other, if they could collaborate with each other, then one agent learning that eating this thing is good for me could be propagated to other agents, and that is what we would call social collaborative AI. Right? Here is a quote from Professor Thor Grapel, one of the key founders or contributors behind AlphaGo, which is one of the state-of-the-art reinforcement learning algorithms, and reflecting the same thought, that we really need to start thinking about AI agents collaborating with each other. Right? And if you look at this problem statement, the value proposition of blockchains for AI starts to become clear. What blockchains provide is a deployment architecture for real-world adoption of such collaborative AI algorithms. Right? Why is this important? In today's day and era, where companies are becoming much more conscious about the value of the data they own, there is a clear incentive for each company to build a wall around their data, saying this is my data, this is my value proposition, I'm going to mine it. Right? But the question then becomes, if you start building walls around data, can you really build powerful AI algorithms? Right? The idea is that can you enable shared learning with private data? Now this is not new. As far back as 2016, there has been work being done. There's a paper that came out from Google called Federated Learning, where they were trying to solve the same problem, shared learning with private data. The context was slightly different. They were talking about saying we want to respect users' privacy, so each mobile phone can help optimize the model without sharing the personal data of the user. In this case, there's one company doing it, but now imagine multiple AI agents in multiple entities, multiple businesses, each learning from their own data, but then collaborating with each other. Right? And that's the value proposition when you look at what can blockchain do for AI. Right? Now, having said that, all these are easier said than done. There are some open challenges when we start to go down this path. The first one of them is if you start making AI agents responsible for transfer of value between two entities, then these AI agents need to be very, very robust. Right? Because if they make a mistake, then the transfer of value gets influenced. So we have to be really conscious about the fact, can vested interests manipulate AI results by manipulating the data it is fed? Right? The second value proposition is liability, or second challenge is liability. Excuse me. If an AI agent actually makes a mistake in determining what has happened in the real world, who is liable? Is it the algorithm designer? Is it the person who provided the data to train this model? Or is there an error in the engineering part in implementing this? Right? The third part of this is incentives. If an AI algorithm is being used and it's a commercial entity, who benefits? Is it the algorithm writer? Is it the people who provide the data to train it? Right? And the last but not the least, how do you build trust between AI algorithms, even with the blockchain fabric? Do we have models like AI reputations and so on and so forth? So these are some of the open challenges at the intersection of blockchain and AI. I hope I have kind of established the value proposition, and that is the first part of the talk. The second part of the talk is where I wanted to make this real, right? Because this was slightly abstract, saying where is this really being used? How is this really useful? Right? The two things that we will focus on is using AI for blockchains. Remember, that is about AI agents acting as oracles for smart contracts, and blockchains for AI, which is basically saying, can we use the underlying blockchain fabric as an incentive layer between AI agents for them to be able to collaborate with each other. Now, if you look at the future of blockchains in the enterprise context, this came out from a recent survey from SAP, where they said 63% identify supply chain as the most promising blockchain use case. Okay. Another statistic that came out was that 76% believed that operational supply chains will be replaced by smart contracts in the next 5 to 10 years. And the total business value impact of this in the next 5 years is in billions and trillions of dollars. So it's very clear that the value proposition is going to be in supply chains. And if you think about it, it is not that surprising. Remember what blockchains fundamentally are. They are multi-entity networks. And supply chains are inherently multi-entity networks. Right? Let's look at this picture. This is a small part of Toyota's supply network. Each node here is a partner of Toyota. And an edge between two parties means that there is some sort of buying or selling or transaction going on between these two companies. Okay? This is the complete Toyota supply network. And the graph that you see on the top is actually all sitting inside SN9. So the point is that even though textbooks show real-world supply chains as chains, where A supplies to B, B supplies to C, and C supplies to D, real-world networks get very, very complex very, very quickly. These networks are complex networks. They are distributed. Information is lying across multiple entities. They are dynamic because relations break and new relations are made, suppliers are onboarded, suppliers are removed. There are multiple decision makers both within the network and even within a company. Right? And there are temporal delays. What do I mean by temporal delays? If you think about blockchains in abstraction, you take a step back and you think about why blockchains are useful for supply chain, you have to realize that supply chains are fundamentally three flows. Flows of goods and services, flows of information, and flows of money. But these flows are going on in very, very complex structures which need coordination among them. And that is where you start to see the value proposition of blockchains or supply chains. Right? So there's a very interesting game. If you have not heard of it, it's called the beer game. And if you want to understand the challenges of supply chain, that's a good game to go and play. It is used as a teaching tool in a lot of the management schools. But fundamentally what it shows is that if you have a distributor, manufacturer, warehouses in all the path, and they don't share information with each other, what are the implications of that? And implications range from out of stocks to overstocks. And just to give you a kind of the challenge scale, the scale of this challenge, out of stocks and overstocks are responsible for the loss of $1.1 trillion globally. Right? That's the challenge. And the kind of problems that we have been talking to our customers and the kind of problems that they face on a day-to-day basis while managing complex networks like these are fairly non-trivial problems. Right? Who should I place an order on? When should I place an order? And so on and so forth. If you look at all this and again take a step back and try to abstract this out as to what is going on, the fundamental problem is that there's a dynamic situation. You're doing dynamic optimization with local decisions. Each entity is trying to do the best it can from its perspective, but what you're trying to achieve is a global optimum. Right? So for those of you who come from a computer science background, this is something like gradient distance or stochastic gradient descent. That's what's going on. Bunch of people trying to solve the problem, but they are not talking to each other, or they are not able to coordinate among each other. And that's fundamentally the challenge, right? So this is what our product is. MarketSense is a product that we have built for enterprise supply chains on blockchains. And what it does, it does three things. It uses blockchains for enable information sharing among multiple entities. It uses smart contracts to align the incentives of multiple entities. And lastly, probably relevant for this talk, is that there's a notion of a market bot. A market bot is an AI agent which acts on the behalf of the organization that deploys that market bot. So if there are 10 entities in a supply chain, each one of them has their own market bot, right? But that does not necessarily mean that that market bot is using the information available only to it. It can potentially use information, or it can ask questions of other AI agents. And that is where the real power of this thing starts to come in, right? Now, distributed ledger and smart contracts, we already talked about, are a natural fit for supply chains for several reasons. But now let's go back to blockchain and AI that we have been talking about and inspect it from the context of supply chains. On the left, we have the AI for blockchain philosophy, that AI algorithms can be oracles for smart contracts. This we have already seen. I talked about how AI algorithms can act as oracles for smart contracts. On the other side, we did not really delve too deep into that, and I would do that now, which is where how do you have blockchain being used for AI? How do you have AI agents, in our case market bots, which are run by each organization, collaborate with each other? The fundamental thing that we use is called reinforcement learning, right? Reinforcement learning, the idea is that agents learn optimal policies by interacting with environment and accumulating awards. So a market bot for an organization recommends certain actions and sees what is the value derived from those actions. This is traditional reinforcement learning, nothing new here. We have been doing this for several years, we know how to do this. What is interesting is multi-agent reinforcement learning, right? This is a scenario where there are 10 organizations in a supply chain and each one has deployed a market bot. Now the question is, are each one of these market bots going to optimize for each organization independently, or can they actually collaborate with each other to do better, right? Do they share state information with each other? Do they coordinate their actions, or are their rewards aligned? This is where it starts to get really interesting and really tough, right? So collaborative AI, the multi-agent reinforcement learning for supply chain, which is what we are working on. This is where the state sits on the blockchain. The state is typically distributed inventory, back orders, in-transit orders. Actions are taken by each agent. Rewards are distributed via smart contracts. Training is done both on private data and shared data based on policies. And the open challenges is how do we incentivize joint actions which are optimal for everybody. As I said, this is work in progress. This is a non-trivial problem, but an interesting direction to take, right? So I will end with this slide and then I'll take a couple of questions. MarketSense, which is our blockchain and AI-based solution for supply chains, fundamentally it supports the creation of business networks, or what we call business groups. The creation of a group leads to one permission blockchain being deployed, and this enables transparent information sharing, reduces coordination costs among multiple entities. The smart contracts that we have built are pre-built, and they work with the existing ERPs, right? So these smart contracts ensure that the B2B transactions are as per contractual terms and can be used to align the incentives in a supply chain. Market bot is our AI agent. One organization gets one market bot. One early release of this is coming by early 2020, but the multi-agent reinforcement learning continues to be work in progress and will take a little while, right? As of September 19, we have deployed in a 4-tier supply chain of 28 companies. And the key ROI that has been measured is reduction in distributed inventory levels of up to 8%, right? March 20, we are planning to get to 100 companies across 4 deployments, right? So that's where we are. That's blockchain for AI. I will take a pause here. If there are any questions, I can take them now. Wait for a mic.
Hello. Yeah, my name is Subin. And I have a question for you. The thing is, you said the regulatory would be AI, right? The reinforcement, like the market bots.
The oracles would be AI.
Yeah, yeah. So I have a question here. Say, for example, it is RL, and there are, kind of 10 market bots, deployed around. So each, five decide on the difference. Five say it is an apple, and five say it's a different entity. So how do you arrive at a consensus when such a situation occurs?
Okay, so this is not an unknown problem. There's a part of machine learning which deals with this, which is called ensemble learning.
Okay.
Okay, and ensemble learning basically says I'm not going to deploy one model, I'm going to deploy 100 models, and each one of these is going to make a prediction, and I'm going to combine these predictions. Now there are multiple things that you can do. You can hard code the combination rule. It could be a simple majority vote, it could be a weighted majority vote, or you can use algorithms to learn the combination function itself. So the idea of combining the output of multiple algorithms has been known. What is new is the incentive structure, because the market bot is not working on any single entities. In our case, each market bot acts on the behalf of one entity. Now the problem gets more interesting if you say that there is a disagreement between these bots. What you don't know is whether the disagreement is because the predictions are different or because the incentives are different. And that's an open problem, right? How do you do that in that case is an open problem. But again, we have the first steps. The first steps are you take ensemble learning and do something with it.
Okay. Maybe you could try the same consensus which we, kind of use in.
Sure. So consensus mechanism, but remember, it is unreasonable to expect that all AI algorithms will get to a consensus. That may not be true for several reasons. Just because of the way algorithms are designed, there might be disagreement. So if you always wait for consensus among AI agents, that may not be the optimal strategy.
Okay.
Thank you. Hi, my name is Janani. So you gave an example of supply chain, so that's good, but I have another scenario. So let's say we have these prediction techniques where we use data, let's say consumer purchasing and his consumers purchasing information to say what sort of buying he'll do in the future. Right, these sort of applications that we have, right? But since morning we've been talking about also security and protection of privacy of information, right? So let's say this lot of applications use credit card purchase informations to sort of predict what would be the future of what this person will buy in the future. So what happens to these sort of applications if these privacy settings are imposed and these data is not becoming available? Because AI basically depends on all data, right? I mean, you need data to make any sort of prediction. You need data, and if you hide them, if you are protecting them, then what will happen to these applications in the future?
Well, it's a fair question, and that's why I kind of said if you look at the value proposition here, the value proposition in the first part, which I said AI for blockchains is, blockchains for AI is that even though you might want to keep your data private, does not mean that you cannot build a model where multiple entities are holding the shared data, right? So here's an example. Let's suppose there are 4 companies. Each of these 4 companies holds certain information about a particular user, right? In today's day and world, either each of these entities builds a machine learning model themselves and they use them independently, option A. Option B says, let's all put together this data in one bucket and learn a much better profile of the customer. This is option B. This is what the large companies have been doing. A lot of companies have been doing this. They buy and sell data about consumers. With privacy laws like GDPR coming in, this seems like a path that's going to shut down very quickly, right? And what we are now asking is, okay, even if these 4 companies cannot share data, can you take the 4 models that they have built and combine the models themselves to do something better without actually having the data move across enterprise boundaries? And that's the whole idea behind MarketBot, that enterprises may not need to exchange data, but they may be able to exchange predictions or models with each other. Right, one last question here because that's the 3rd question, and then we'll stop.
Hi, I'm Ashish. I'm trying to build a supply chain app on decentralized only. My question is that I have a historical data of consumption, whether it is in a factory or a retail store. Now, how can which is the best tool to make predictions and pass on that oracle to the smart contract? That what would be the seasonal fluctuation, or could it be a festival fluctuation, or any other fluctuation that we have? We know it pretty clear, like for a retail market, Diwali season, whether it is in October or November, the sales shoot up. So how do I feed that data? Which is the best tool to make predictive analysis in such a case?
Well, so there are two parts to this, well, there are at least three parts to the answer. Tools, algorithms, and then the people who optimize this, right? There are a bunch of tools now available for building machine learning models, starting from open source tools like Python and R, which are the basic tools, to scalable models where Azure and AWS and Google, all of them provide AI as a service. So that's the first part of the answer as far as tools are concerned. Now, in terms of which algorithms should you use, in time series forecasting and for demand forecasting, there are some well-known tools, primarily from time series forecasting. But you could, unless you try these algorithms out, it's hard to say which algorithm will work best for your data. But there are well-known algorithms which can be used for this. And third, you probably need somebody like a data scientist or a machine learning engineer to try these algorithms out for your data and say, this is the optimal algorithm, and then deploy that algorithm on the tool which is available on the cloud. Yeah, thanks. All right, thank you.